Okay. Good morning, class. Please mute your mic. Only if you have a question, either you have to raise your hand, then I will allow you to open your mic, okay? So mute your mic to avoid some noise. Zannaba Gamachu and Dawit, please mute your mic. Okay. Thank you very much. Good morning, class, once again. So today we're going to continue from the discussion that we started last time. Last time we were talking about, some of the challenges that we have in language processing, or whenever we develop an NLP application, there are challenges that, we face. And whenever you write a program or whenever you write a computational system, you have to be, you have to recognize these challenges, or we call them anomalies. Anomalies are some of the challenges that we face at different level of language study. So we are going to try to see each of them by taking some examples from the English language. If you remember, we said whenever we study language, we have many different levels. If you recall, we talked about, different levels of language study. And from these different levels of language description, as we have seen last time, one of the challenges that we face is pragmatic anomaly. Pragmatic anomaly means sometimes whatever you write should not be interpreted as it is. If you remember, we took an example for Amharic. For instance, if you say, if you have this, if you have this sentence, okay? If you have this sentence, we know that the person is not interested about cooking something for you, right? Actually, maybe he means, I don't care. Or he might mean, so what? Okay. This is the meaning that we have from this phrase, doesn't mean that I want to cook something for you. So sometimes we have such kind of a challenge. For instance, if you see this English sentence, next year all taxes will disappear, we know that it's not true. So this is some of the challenge that we face. So at a pragmatic level, we know that whatever you have written, either a word or a phrase or a sentence, doesn't literally mean the meaning of the words or the meaning of the phrase, because societies use those words or those phrases to mean so many other things based on their own context, based on their own culture, based on their own conversational standards or norms that they have. The other kind of anomaly that we have in a language is semantic anomaly. For instance, if you see this sentence, it says a computer ate an apple. What is the problem with this sentence? Zanaba? What is the problem with this sentence?
The computer is a thing.
Okay.
So it can't eat an apple.
It can't eat an apple, right? What if I change the same sentence in such a way? What if I say, the boy ate an apple?
The boy ate a person who ate an apple at the last time.
So now the problem that we see in here is we know that the noun or the object computer, mind you, both are nouns, whether you have the word boy or the word computer, both are nouns. But one thing that we know, from logic or from semantic, but something that we know is a boy is an object that can perform the action of eating, while a computer is not an object that can perform the action of eating. So it's only this relationship, it's only this logical relationship that, forces us to say this sentence is incorrect. But the rest of the things are the same. Both words are noun. We have the same verb, but we know that one of the noun cannot engage in that action, whereas the second one can do the job. So it is only due to this reason we say that this sentence is incorrect, okay? If you see the word class for each of them. And if you see the word class for each of them, the first word, which is the, is a determinant, we know. The next word, either a boy or a computer, is a noun. 8 is a verb. An is an article, okay? And then apple is a noun. So we know that such kind of relationship can occur. We know that in English, a determinant, a noun, a verb, an article, and a noun can follow up in this order. So as you can see, both sentences are having this structure. So when it comes to the structure, okay? When it comes to the structure, or we also call it syntax, when it comes to the structure or the syntax, both sentences are correct using the English language. If you see from morphology perspective, mind you, morphology is the word formation, the way you create the word. If you see each and every word in these two sentences, they are correctly organized, which means there is no morphological problem in each of the sentences. So when it comes to the structure or the syntax or the order of words, they are correct. When it comes to the formation of the word, it's correct. But when it comes to looking into the relationship between the words, one of them have a problem, which is one of them, which is the first one, is trying to relate an object with an action that's not correct, because we know that the computer is not an object that can perform the action of eating. So whenever this happens, we say this has a semantic anomaly. Semantic is at a meaning level. The meaning, the logic of the relationship between the words is incorrect. So that's why we say when it comes to this sentence, the sentence that you see in here, the sentence that you see in here, the computer ate an apple, has a semantic anomaly, a problem that's associated to the meaning, that's associated to the logical relationship between the words. So this is some of the challenges that we have, mind you. Whenever you want to construct a sentence or whenever you want to understand a sentence using a computational system, there are many levels of understanding that you have to go through. We have, if you see it at a text level, we have morphology, okay, which is concerned about how words are formed. We have syntax, okay, which is concerned about how words are ordered. Let me give you a very short phrase to understand this one. This is concerned about word formation, okay? It's concerned about how words are formed. Syntax is concerned about how words are ordered, okay? Then we have what we call semantic, which is concerned about how words are related to one another. We have also pragmatics, which is concerned about the intention of the speaker, rather than looking into, the literal meaning of the words. We are interested about what the intention of the speaker is, or the intention, or we can say the objective, what the speaker wants to achieve, okay? So all these words or all these levels of language understanding have their own challenge. So for example, if you look into the word formation, it is concerned about how the words are created. For instance, how is a past tense created in English? For instance, we have the word, let's say, talk, okay? And if you want to create the past tense of this one, you'll say talked. So this is perfect. But what if you have the word, for the same language, what if you have the word cut, okay? We know that the past tense of cut is cut, but if you say cutted, we say this has a morphological problem because the past tense of the word cut is cut itself. So we say this is a morphological problem or a morphological anomaly. When it comes to syntax, we are concerned about how words are ordered. Now we know that in English, for instance, we can have a determinant followed by a noun, followed by a verb, then another determinant followed by a noun. You can have this structure. So you can have a sentence of such a sort, like you can say, the boy talked the girl, or the boy likes the girl, okay? You can say this. So there is a determinant there is a noun, there is a verb, there is another determinant, there is also a noun. But what if I have such kind of a sentence, okay? if I say the like boy, the girl. So in this case, if you see, this is a determinant, okay, followed by a verb, followed by a noun, followed by a determinant, followed by a noun. So we know that such kind of order is not allowed in English. So what we say is this sentence has a syntax problem. Okay, the problem is syntax because the English language doesn't allow a determinant to be followed by a verb in such a manner. So we say this is a syntax problem. The other one is semantic. Semantic is concerned about the meaning. It's concerned about the relationship between the words. Rather than the order, it is concerned about how words are related to one another. So the sentence that we have in here is a good example. If you say the computer ate the apple, then we say this sentence has a semantic anomaly or problem because we know that a computer is not a noun that can perform the action of eating. The last one is pragmatic, which looks into the intention of the speaker. So these are very critical levels of understanding that we have to know about a language. So the next thing that we have in here is a syntactic anomaly. It is concerned about the syntax, okay? When it comes to the syntax, we say the computer ate an apple versus and the ate apple computer. So in this case, we know that the order, mind you, this sentence has both problems. It has a semantic as well as a syntactic problem. You can say the computer ate an apple has only a semantic problem. But if you look into another version, which says, and the ate apple computer, or let me give you another sentence with only a syntactic problem. You can say the car is red. So you can say the car is red. But what if I construct another form with the same words? What if I say the is red car? Mind you, I'm using the same words. So in this case, we say the second one has a syntactic problem because the way I organize the words is incorrect. And we call this one a syntactic anomaly that we have from this sentence. So you have to be concerned about this one. The other one is a morphological anomaly, which we have said earlier. Morphology is concerned about how words are formed. So in this case, if you say the boy ate an apple, then what do you think is the problem? Gamechu, what do you think is a problem with this construct? Gamechu? Okay. Okay, Andu.
Yes.
What's the problem with this sentence?
The problem of it not changed to ed forms.
Exactly. So actually, in here, the problem is how the word is constructed or how the word is formed. Where we know that in English, the word eat, if you want to change it to past tense, it would be it should be ate, not eaten. So you see that this is a morphological anomaly. The problem is on how the word is formed. It's not about the order of the words. It's not concerned about the relationship between the words. Even how the word is constructed might be a challenge. It might be an anomaly from linguistic perspective. So the actual sentence should have been, the boy ate an apple. This is a correct sentence. So the problem in here is how you create the past tense of the word eat. See, it should have been ate, but you have written it as eaten. So we call this one a morphological anomaly. Anomaly related to how the word is formed. Mind you, you have to see the relationship. Morphology is concerned about how words are formed. So any such kind of a challenge, we call it morphological anomaly. Syntax is concerned about how words are ordered. So what we call syntactic anomaly is a problem on the order of the words. Semantic is concerned about the meaning of a word and the meaning relationship between words, which is a logical relationship And any such kind of problem, we call it a syntactic anomaly. Pragmatic anomaly is concerned about how you can interpret whatever the speaker has written to identify the objective or the intention of the speaker. So these are common challenges that we face in linguistics. The other one is lexical anomaly, which means the words might be correct, okay? The words might be correct. The order of the words based on the part of speech or the word class might be correct. Mind you, when we say the part of speech or the word class, we are concerned about whether a word is a noun, a verb, an adjective, an article, or so and so. So it might be correct. The order might be correct. The spelling might be correct. But such kind of word lexical attachment might not be allowed. For instance, if you say colorless green ideas sleep furiously, you can see that you have an adjective, another adjective, a noun, a verb, and an adverb. That is allowed in English, mind you. This order of part of speech, this order of word classes is allowed. But have a look at the relationship between the words, like colorless green, okay? Then colorless green ideas, then sleep furiously. As you can see, even though the words are correctly written, even though the order of the words based on the part of speech is correct, we know that such kind of lexical relationship between the words does not exist in English. But if you have it in such a way, if you see beautiful red dresses shining amazingly, as you can see, this is an adjective, red is an adjective, dress is a noun, shining is a verb, and amazingly is an adverb. So as you can see, it is a correct construction. So even though the words have the same class, even though the order is correct, it doesn't mean that those words can align to one another or they can co-occur with one another. Words would have a preference. Words prefer to occur with some other words to make some context or to give some meaning for the context. So such kind of anomalies, we call them lexical anomalies. Saying this much about the anomalies, now let's spend some minutes about talking about some of the language technology applications or NLP applications that we have. Mind you, this slide is showing you only what has been done for English or for those languages that are very rich in terms of, or very highly resourced in terms of corpus, in terms of NLP applications, in terms of research, in terms of fund, and so and so. So now it is classified into three groups. The challenges that are mostly solved, the challenge or the applications or technologies that are making good progress, and those that are still very hard or difficult, even for those highly resourced languages. Mind you, when it comes to our local language, we know that we belong to the part which is still very hard or making very few progress, okay? Some of these applications, mind you, this list is not exhaustive. This is just to give you a highlight. Some of the applications are, for instance, spam detection. If you look into an email, we know that your email provider filters the incoming email into two groups. Some of them are spam, some of them are not. And identifying a spam email from a non-spam is a linguistic application. Because to identify something is a spam, what do you need, for instance? What do you need? Marta, to say that an email is a spam, what do you need? Marta. Marta? Marta. Okay, تكتل.
Okay.
تكتل. To say that an email is a spam, what do you need to do?
Email by itself handle it by seeing or the email it solves it, and when the spam is occur on the message, it included in the spam part.
Yeah, that's true. But to do that, to include it in the spam folder, there must be something that the mail server has to do. For instance, what we call a spam. Most of the time, what we call a spam is, let's say, a marketing email, right? A promotional email, something that says, you know, there is a computer that is sold in discount, or there, it might say there is a drug that you can buy, you know, off the shelf or something like that, okay? So it's an email that you don't want to see. And most of the time it's either a marketing or a discount offer or so and so. So to identify that, what you have to do is you have to look into the content of the email. Maybe you have to see the subject, maybe you have to see the sender, maybe you have to see the internal content of the email to say whether it's a spam or something that's not a spam. Or to say that it's a ham or a spam, what you have to do is you have to look into the words. For instance, if it says buy a drug, then it tells you that it's a spam. If it says it's a discount, or you can see also part of the email. You can see the internal content. So by doing that, you can say one of them is a spam, one is not a spam. You can make such a decision. Or even part of speech tagging to identify whether a word is a noun, a verb, or an adjective. Mind you, it's not a simple task. So you have to actually be concerned about how to tag a sentence. For instance, how do you tag this one? Okay. If I have the boy saw the saw. Okay. Now, what are the parts of speech of each of these words? What are the word classes of each of these words? Anyone?
Determinant.
Determinant, okay.
Noun.
Okay.
Verb.
Okay.
Determinant.
Okay.
And noun.
Now you see, there are, you know, we have the same word, S-A-W, S-A-W. But at one time you call it a verb, at another time you call it a noun, right? Now, how do you make this distinction? How do you make this distinction? Mind you, it's the same word.
Yeah.
So the task is not a simple task. There are ambiguities. There are some challenges, okay? So performing this job is, you know, it is mostly solved, but it is a computational task. The other one is named entity recognition. What we call named entity recognition is, in a sentence, all parts of the sentence are not, you know, always the same. For instance, you might have this one. You might have this is Addis. If I say this is Addis, what do you understand? Mind you, what we call named entity recognition is a name of a person, a place, or an organization in a sentence. So if you say this is Addis, we are concerned about only the name of either a person, a place, or an organization. So in here, the most important word is only the word Addis. If it is a name of a person, it can be name of a person, Adallah. Here it can be name of a person, or it can be name of a city. Okay, you can have this one. But what if I say this is Addis Ababa? What if I say this is Addis Ababa? Now it is, instead of, you know, one of the two, it would be only name of a city. Yeah. So from this sentence, I'm interested about only the phrase Addis Ababa. I'm not concerned about the rest. What if I say this is Addis Ababa University? Now in this case, it is going to be name of an organization. You see? The same word Addis, based on where it exists, it can play so many things. So what we call named entity recognition is a task of identifying name of a person, a place, or a location. So if you say Einstein met with UN officials in Princeton, then from this sentence, we are going to be interested about only the words Einstein, okay? Einstein, UN, and Princeton. The rest of the sentence are not important for us because named entity recognition is concerned about identifying, you know, name of a person, a place, or an organization. The ones that are making good progress is, for instance, sentiment analysis. By looking into a comment that's posted on Facebook, Twitter, or anywhere, you can see whether that person's feeling is positive or negative about the post. And for that, you have to look into adjectives, you have to look into intensifiers, you have to look into polarity shifters. For example, if you say based roast chicken in San Francisco, the word based is going to show you that the person is having a positive sentiment about something. If you say the waiter ignored us for 20 minutes, then the word ignore is having a negative sentiment by itself. Being ignored is not positive. So you can say this person is having a negative sentiment. So by looking into what people have written, you can decide whether the person has a positive or a negative feeling towards something. And this is very important for product rating, for product improvement, for identifying people's perception towards a political view, a government, an education, a policy, or so and so. And by looking into the meaning of the words or the intention, what we call the polarity of the words, you can decide whether it's positive or negative, okay? So you can give it a 2-star, a 5-star, a 1-star based on the words that's contained. Co-reference resolution, which means we know that we have such kind of pronouns which can play many roles. For instance, the word he in here might refer to Carter or Mubarak, we don't know, okay? So identifying this one is another challenge. Word sense disambiguation is another language technology application that we have. For example, if you say, I need a new battery for my mouse, we know that the word mouse can be the animal or the computer mouse. Now, how do you know that this is a computer mouse? How do you know?
Depending on the context of.
Yeah, how do you identify the context? By looking into the word battery, you know that it's only the computer mouse that needs a battery. The animal doesn't need that. So at this point, deciding whether this mouse is the computer mouse or the animal mouse is a challenge that we have, okay? It is a very important thing that you have to look into. For instance, if I have this one, okay? If I have this one, what do you understand? What do you understand? Yeah? You see, it might be, he just came, or it might mean,
holiday.
Christmas.
It's here. I don't know. It might mean both. Now, which one do I mean?
He just came.
We don't know. Both are possible. So you have to look into other context. Okay? ለምሳሌ እንደዚህ ብታገኙስ?
He just came.
እንደዚህ ቢሆንስ?
Still, it works for both.
ለምን?
Cause ክርስማስንም ልንጠብቀው እንችላለን። የሆነ ሳማ ዘርበድም ልንጠብቀው እንችላለን።
አሁንስ ተጠብቀው ቆይቼ አሁን ገና መጣ ካለን then we are referring to
he just came.
He just came, right? What if I say እንደዚህ ብልስ? Then in this case, it might mean Christmas, right? Now, this is what we call is word sense disambiguation. Some of the words, like the word Ghana, is ambiguous. It might mean Christmas or it might mean not yet. And to identify which one we are trying to refer to, looking into the context is very important. Okay, it's very important, and that's what we call is word sense disambiguation. We have a chapter on this one. Okay, the other one is parsing, which means identifying the grouping of the words is also very important in computational linguistics. Like you can have words like this one, okay? You can say, if I have ረጅም መኪና አጣቢ, who is ረጅም? Yeah? Who is ረጅም? Exactly, based on how you group them. Like, for example, if you group it in such a way, it is a car that is long. And if you group it in such a way, then it is the person who washes the car who is tall. Okay, because the word regime can actually quantify either of these two. Either it can quantify mekina or it can quantify atabi. In this case, atabi is a noun. Mekina. So whenever you say mekina atabi, you are referring to one type of noun. Then if you say regime mekina atabi, it means regime is referring to the person who washes the car or atabi. In the first case, if you group it in such a way, then you are referring to the car. So grouping of the words is concerned. I mean, parsing means how you are going to group the words. And parsing is a challenge for linguistics or for computational linguistics. So it is mostly solved. We have machine translation, which means translating from one language to the other is making really good progress, changing the sentence from one language to the other. Information extraction is another challenge, which is mostly solved, which means extracting some elements from a text. For instance, extracting only the calendar from a text is information extraction, which is being done very efficiently these days. Those that are still a challenge are question answering. Question answering, if you have taken information retrieval, is concerned about giving an exact answer for the question that you have provided. It's not going to give you a document. It's not going to give you a larger text. Paraphrasing is another major challenge that we have or a task which is still very difficult for computational linguistics, which is concerned about, changing the structure of a sentence by itself. Text summarization is another challenge that we have, especially what we call abstractive text summarization is a challenge, and a dialogue system, which means a speech conversation with a computer, is another challenge, or still it is an application which is being very difficult for especially morphologically rich language. So these are some of the applications. Some way in the course, we are going to touch upon most of these applications that we have, okay? So after the break, we are going to talk about these applications.